explain the terminologies of flight control, let us start off with open loop system and closed loop system in this session. Open loop system. It is a system in which the output is dependent on input, but controlling action or input is totally independent of the output or changes in the output of the system. It is represented as the diagram shown here. Reference input or the required process input is applied to the controller, which generates the actuating signal or the output of the controller, which is required to control the process which is to be controlled. Process is giving out the necessary controlled output. The advantage of the open loop system are it is very simple to construct, very much convenient when output is difficult to measure. Such systems are easy for maintenance point of view. Generally, these are not troubled with the problem of stability. Such systems are simple to design and hence economical. There are few disadvantages of an open loop control system, which is such systems are inaccurate and unreliable because the accuracy of the system are totally dependent on the accurate pre-calibration of the controller. Such systems give inaccurate results if there are variation in external environment, such as system cannot sense the environmental changes. Similarly, they cannot sense internal disturbances in the system up to the controller stage. To maintain the quality and accuracy, recalibration of the controller is necessary from time to time. We have an example of open loop control system, which is wing leveling manually. The control system concept is to implement the desired control function manually, which can be presented in simple block diagram shown here. So this shows the manual way to maintain a wing level altitude by the pilot control. When the pilot column is moved, the command of roll angle is entered into the controller, which in turn commands the aileron servos to adjust commands the ailerons of the aircraft to roll on the right or left. Hence, the pilot uses the pilot column to adjust the aileron servos to roll the aircraft. But the disadvantage of this open loop is that the output of the control system is final and there will be no change in the input signal if the aircraft is not leveled. Again, the pilot has to adjust the pilot column to make the aircraft level. It is not an automatic process. It has to be done manually. Now to closed loop control system. It is a system in which the controlling action or input is somehow dependent on the output or change in the output. To have dependency of input on the output, such system uses a feedback property. So the feedback element here is the feedback is a property of a system by which it permits the output to be compared with the reference input to generate the error signal based on which the appropriate controlling action can be decided. In such system, output or the part of the output is fed back to the input for comparison with the reference input applied to it. Here we have a closed loop system which is represented in the block diagram. R of t is the reference input, E of t is the error signal, C of t is the controlled output, M of t is the manipulated signal, and B of t is the feedback signal. So depending upon the nature of controller and plant, it is required to reduce it or amplify it or to change its nature, that is make it discrete from continuous type of signal. This changed input as per requirement is called reference input, which is to be generated by using the reference transducers. The main excitation of the system is called the command input, which is applied to the reference transducer to generate reference input. Practically, the part of the output which is to be decided by the feedback element is fed back to the reference input. The signal which is output of feedback element is called feedback signal B of t. It is then compared with the reference input giving the error signal E of t is equals to R of t plus B of t, that is error signal is equals to the sum of reference input plus the feedback signal. When feedback sign is positive, systems are called positive feedback, and if it is negative, it is called a negative feedback. This error signal is then modified by the controller and decides the proportional manipulated signal for the process to be controlled. This manipulation is such that error will approach zero. This signal then actuates the actual system and produces an output. As output is controlled, it is called a controlled output, C of t. So the main advantage of a closed loop system is that accuracy of such system is very high because the controller modifies and manipulates the actuating signal. Such system senses the environmental changes as well as internal disturbances and accordingly modifies the error. In such system, there is reduced effect of non-linearities. Bandwidth of such system is operating frequency zone for such system is very high. Apart from this, there are few disadvantages also where such systems are complicated and time consuming from design point of view and also costlier. Due to the feedback system, it tries to correct the error from time to time. Tendency to overcorrect the error may be oscillations without bound of the system. Hence, the system has to be designed taking into consideration problems of instability due to the feedback signal. The stability problem are severe and must be taken care of while designing the system. We also have the automatic wing leveling example for a closed loop control system. Here, the control system concept is to implement the desired control function automatically, which can be represented in a simple block diagram. Below shows the autopilot to maintain a wing level altitude. Here we have the command role which is given automatically to the controllers, which tells the aileron servos to level the aircraft by controlling the ailerons of the aircraft. If through gyro the autopilot gets to know that the aircraft is not leveled and the wing is not leveled, it makes an error signal to the controller again, which is a continuous automatic process to attain a zero error, and hence automatically the autopilot will level the flight and there will be no input by the pilot again and again to correct the leveling of the wing. Comparison of closed loop and open loop control system. Any change in the output signal has no effect on the input signal for open loop, but any change in the output signal has an effect in the input signal is a closed loop. The feedback element and error detector is absent in an open loop control system. In closed loop control system, feedback element and error detector is present. Open loop control system is inaccurate and unreliable. Closed loop control system is highly accurate and reliable. Open loop control system is highly sensitive to disturbance and environmental changes, but closed loop control system is less sensitive to disturbances and environment changes. Open loop control system is simple to construct and cheap, but closed loop control system is a bit complicated to design and costly. Generally, unstable in nature is our open loop control system, but stability is the major consideration while designing is a closed loop control system. Bandwidth is small for open loop control system and bandwidth is very large for closed loop control system. I hope you would have understood what is open loop and closed loop control system and the comparison of open and closed loop control system. Let us start off with the controllers and type of controllers in the next session. Thank you.